Hello everyone, welcome to another short video. In this video, we are going to look at Palo Alto's Layer 3 interface type with IPv6 addressing. And our aim in this lab is to have a communication established between VPC2 and VPC3, where both sit on the IPv6 network, and also VPC2 and VPC3 should be able to reach out to internet to the address 8.8.8, but that will be happening with the help of NAT 624 translation. So I'll discuss NAT 64 translation when we look at the NAT policies, but in this lab, you will get a know-how of how the things really look like in terms of a NAT 624 translation. So there is a dedicated range for NAT 624 translation assigned by the IANA, and that range is 64 colon FF9B colon slash 96. And if you try to represent 8.8.8.8 into that IPv4 to IPv6 translation range, then this 8.8.8 will be represented as this. Let's jump onto the firewall and do some configuration for it. Let's configure ETH1.1 first. 1/1, sorry. Yes. Let's make it layer 3 type. And then virtual router, VR. And then let's create a quick zone for it. Zone, LAN zone 1. And then assign IPv6 address. First enable IPv6 address. Add here FC00 colon 1/64. That's my IP address. I am going to enable the router advertisements, and these are required for the SLAAC, which is stateless address auto configuration. It's like DHCP for the IPv6 networks. Let's enable that here as well. Okay, one interface is configured. Let's configure the other interface as well. Layer 3, VR, default VR, security zone. Let's create another zone. LAN zone 2, IPv6, enable, and then let's add IPv6 address. For this interface, we will have FC00 colon 0 colon 0 colon 1 colon 1 slash 64. Enable router advertisement, and sorry, IPv6 in here. So enabling router advertisements will help to give VPC2 and VPC3 the IPv6 addresses automatically from the on the IPv6 network. Now this is done. Now let's create a quick policy as well. LAN 1 to LAN 2 and LAN 2 to LAN 1. So we want to enable the bidirectional communication. That's zone 1, LAN zone 2. Yeah, let's make the policy as type interzone. Traffic between LAN zone 2, LAN zone 1. Everything, nothing. I'm going to not touch anything here. Allow, log the session at the end. That's it. Now this is done. Let's commit our changes. Once the changes are committed, I should see a IPv6 address on this VPC. So IPv6. Right now there is no global scope address. Let's see, the same will be the situation on the VPC3. Show IPv6. Yes. Once the commit is complete, they should have a global scope address along with the router link clear address. Now let's wait for the commit to complete. The commit is still in run. There we go. Now let's see if our VPCs have got an address on them. You can see it has got an address. This one also. Now this address should be pingable from here. Ping. You can see it can ping. Now this should be able to ping this address. That's it. They both can ping. Let's check in the firewall logs. Monitor. Uh, the recent logs for us are these ones. Starting here, these are our logs. So you can see in both the directions, lens zone 2 to lens zone 1, this has been working, and also other side log would also come. Yeah, see, 1 to 2. Perfect. Now I want these two machines which sit on the IPv6 network to communicate with 8.8.8, which sits on an IPv4 network over the internet. So for that, we will do some net 624 stuff. But first, let's configure our WAN interface. I'm going to use ETH1 by 3 as my WAN as per my topology. Yes, it will be a layer 3 interface, and I'll add it to default VR. It will have a different zone. This should go in the WAN zone. I want to make it capital. WAN zone created IPv6. Let's assign address 253.201/24. Address assigned, and yeah, I'm going to add an address here which is used for NAT 6 to 4 basically translation, so that I do not need to put a route for it in the default router. That's fine, but I'm not gonna enable the RA, so this is fine. Added, nothing. Yeah, perfect. But let's add a default route to our VR for the IPv4, but IPv4 will be require the route because now I have not added that in there. Sorry, 0.0.0.0, and the destination is my bad. I need to type here default. Okay, destination interface. I'll choose ETH1 by 3, and IP address is the next hop as the IP address 192.168.253.2. That's it. Right, okay, and I'll create a NAT policy as well, and I also need one security policy. Hmm. Let's do it a bit differently this time. Select it, clone it, and I want to put after rule this. Yes, so it has created here and added the name first, LAN to WAN, and then interzone source, these two, destination, just remove them and just add the WAN zone here. Everything else stays default. Perfect. That's it. Now let's create a NAT policy. The NAT policy is very important in this case because this is where it's gonna happen. NAT 6 to 4 translation. Yes, and let's select the policy type will be NAT 6 to 4. Original packet, the packet can come from LAN zone 1 or LAN zone 2. It will be going to WAN zone. Any interface is fine. What will be the destination addresses? Destination address will always be in this range so that NAT 6 to 4 translation can happen, as this is the assigned range by the IANA. And then I want to translate the source on an interface address, and interface is ETH1 by 3. Use this IP address, hit OK. That's it. Now let's commit. Once the commit is complete, these two VPC should be able to ping the Google's, uh, you know, 8.8.8, but 8.8.8 will be pinged in this format from our IPv6 socket. So let's enable 64 colon FF9B colon 0808 and colon 0808. I'll wait for my ping to complete. Commit to complete. Yeah, commit is about to complete. Yep, commit is now complete. I will leave it under the monitor. Let's do the ping. See, it's working. Just what timeout. And here, from here as well, it should work. It is working. You can see it can ping. But now let's see a log for this 0808 address on the firewall, and that will be the magical thing. Yeah, you can see these. So let's check for first of the machines. So let's check this log, which says it went from LAN zone 1 to WAN zone. You can see source is IPv6 address, and then it has been netted to IPv4 address, and then destination is a IPv6 address that is netted to 8.8.8. So it means it is pinging 8.8.8. So that's how the translation happens when a net 64 is used. That's it for this video. Have a good day.